Assalamu alaikum everyone. Today we are going to learn about pandas. And don't worry, I'm not going to make it boring and complicated. I'll keep it super simple, beginner friendly and step by step so you actually understand what you are doing. Not just watch and forget. By the end of this tutorial, you'll be able to use pandas for real world data analysis. Like handling dataset, cleaning messy data and doing powerful thing with just a few lines of code. So yes, stick with me till the end because this one skill alone can completely change how you work with data. So what is pandas? Well, think of it as your data assistant in Python. You give it messy data and it organizes everything like a super smart office manager. You have tables, it handles them. You have CSV files, no problem. You have huge datasets, it doesn't even switch. In simple words, pandas help you understand, clean, analyze your data in Python easily. Now, first of all, I'm going to create a file with name of 01 introduction.py, and one more thing, you need to use this Python extension, Python. Just search for Python. If you are using Cursor AI, the search option, extension search option is here. Just click on Python. This is the official one from microsoft.com. Let me just install it. Once you have installed it, now the next step is you need to open the terminal. If you are using Windows, the process is little bit similar, but you need to open PowerShell instead of terminal. Okay, now go to the directory where you are working on. For me, it is videos, web dev lab, then single tutorial 003 Python Pandas CDEN. Let me just clear the screen, and here I need to install pandas and other packages we are going to need for this tutorial series. First of all, I need to set up the environment. If you want to use virtual environment, that is totally fine, but in this video I'm going to use UV, which is a latest package manager for Python. So I'm going to use it, uv.init, and it created my project successfully. Now I'm going to create a new file with name of requirements. If you worked with any Python projects before, you know what this requirements.txt file is. This is actually the list of all the packages we are going to use in this project. I have listed them all. Now I am going to install all those packages by using this command uv-add-r requirements.txt. It will install all those packages which is installed inside requirements.txt file. You see the list of all those files. Now at the top I am going to import pandas from pd and import NumPy actually as np. It will be as, not from. First of all, let's create a series from a list. So let's do it. Simple series is equal pd dot series, then it will be a list of Python 10, 20, 30, 40, 50, something like that. Let's print out the series. Print simple series. Let's see. uv run 0 1 introduction. Let's see the series. It is data type integer 64, you see, and this is the list. Actually, how this works: PD series converts a list like object into a series. Let's see all those values by this. Let me just again print it out. You see the series value as NumPy array is 10, 20, 30. Actually, it should be 30, and this is how I printed. I just made a string, f string. With that, I just get all the values. Now this time let's get indexes instead of values. So the way of getting indexes is this: simple series.index.toList. We are going to convert this index to a list. So let's see how this looks. And this is the series index, and this is series values. We have created a series successfully. Now we are going to create data frame of pandas using a dictionary. So let's do it. Student underscore data is equal, this is the dictionary I was talking about. This name is going to be Alice, comma Bob, comma Charlie, comma Diana, Dinah, comma, let me just copy this and paste it below 3 more times. This one is going to be age, third one is going to be grade, and the last one is going to be score. Score will be let me just get rid of this. The score will be 93, 45, 86, 75. You can just set any score you want. Let me set the age as well: 32, 23, 24 and 25. Let's change the grade as well. The grade will be A plus, comma B minus, actually like this, A, comma B. Now let's create the data frame. df underscore students dot is equal pd dot data frame student data. Now let me just print it out. Print df students. Save it and let me just run it again. This is what we get. We get name, age, grade, score, and this is the indexes 0, 1, 2, 3, 4, and for each name we have value of name, Bob, Charlie, Dania. Now let's create data frame from NumPy array. So below here, NumPy data is equal np, which we have imported here, np dot random int, and the random value will be from 1 to 100. Size is equal 5,3. df data frame from NumPy is equal pd dot data frame, and in here NumPy data comma columns is equal and array feature A. Let me just copy and paste beside feature A, B and C, and let me just print it out. Print NumPy, actually df from NumPy. Save it and again run this. We got an error data. Yeah, this is the problem. DataFrames underscore init got an unexpected keyword argument which is columns. That is true. Then the column spelling is not like this, columns. This is the correct spelling. Let me just run it again. Yeah, here it is. We got the value from NumPy array. If I want to do like this, let me just copy this and paste it below here. If I want to get values values, then I can also get them just like this. Those are all values from here, no indexes, which is 0 1 2 3 4. We are only getting values. So hope you understand. Now we'll talk about some attributes and basic information about DataFrame. Print, let me just add this multiplied by 40. Okay, now let's use print f. This is an f string. Shape of student data frame is going to be df underscore students dot shape. This will actually return tuple of rows and columns. Let me just save it and run this again. This is what we get, shape of student data frame, which has 3 columns and 3 rows. Yes, 4 columns and 4 rows. This is the shape. Let me just copy and paste it below. Now we are going to get columns instead of shape, columns. Let me just write columns and again run it. Yeah, it is getting object no NS. I always make a lot of spelling mistakes, so just forgive me. Yeah, we got all the columns of student data frame, which is name, age, grade and score. Before we start, if you are already enjoying this, please like, comment and subscribe. It might look small to you, but for me it really means a lot more than you think. Just one click from you can genuinely make my day better. Now let's move to something really practical. File operation using Pandas and NumPy. Because in real life, you are not always going to type data manually. Most of the time, data already exists in files like CSV or Excel sheets. And your job is to read the data, work on it, and sometimes save it back to a different format. And this is where things get interesting. Now let's create another file with name of 002-file operation let me just rename it. From now on, I'm not going to use this cursor AI. Instead, I'm going to use PyCharm. Here I'm using PyCharm. Let me just open my folder which is inside these videos. Videos, web dev lab, then in here single tutorials, Python Pandas and EN tutorial code. This is where a task project. So let me just click here, task this project, and let me open it, introduction.py. Let me just make it little bit bigger so you can see it properly. Okay, go to editor, general, font, inside font. Let me just make it 16, actually not 16, let's make it 18. Apply, and I think you should see this properly. Let me just make it 22. Let's make it bigger. And then in appearance, you also have the option for increasing font size. Use custom font. Let's go with Liberation Serif, and let's make it 18. Apply and OK. And one more setting I need to change. From here, go to settings. Go to settings, go to Python interpreter, and in here add local interpreter, select existing. This is already selected our VNV Python file from this, actually not this one. I'm looking for Sion videos, and in here web dev lab. Then go to single tutorials, Python Pandas, EN tutorial code. This is the one I was looking for. .vnv, bin, and Python. If you have installed all the packages using UV successfully, then you should see these two. Again, let me import Pandas and NumPy. Let me import it at the top. Then again I'm going to import JSON and import IO from IO, import a string IO. And let's create a simple data for demonstration actually. Let me just copy and paste it here. Don't worry, I have included the link of my repository of this project in the description of this video. So you'll get this. Let me explain it. Instead of writing all of this from scratch, which is a lot of time consuming things, let me explain it. This is just a static data, nothing fancy at all. This is actually a dictionary. Here are all the keys inside the left. Here are all the keys in left side, and on the right we have values. This is key, customer name, product name, category, and with this colon, after everything after this colon we have all the values in an array. So let's make data frame from here. df underscore orders. It is auto completing, so let me just press tab. pd.dataframe is equal simple orders data. Let's see how it looks. Print df orders. Terminal, instead of 01 uv run 02 file operation. Here are all the data we have got here. We have a table. Here are all the keys of the object in data format, which is a header row, and these are all indexes 0, 1, 2, 3, 4, 5, 6, and these are all values we have in here. Okay, hope you understand. There are 7 rows and 8 columns in here. And you might have noticed one thing, which is it is not showing all data. Instead it is giving this dot sign. Don't worry, so you don't have to scroll for a long data. Now open DeepSeek or any other chatbot, search for create a CSV file with 120 and there will be more than 5 columns. So it will create the file. Okay, now I got the response. Let me just copy this and paste it here. I'm going to create a new file with name of orders.csv, and here it is, not data. Let's select text. Let me just paste it and let's go to data. In here I have order ID, customer ID, order date, product name, etc. I'm going to use it. In here we have printed df order successfully. Now I'm going to read the CSV file with this df from CSV is equal pandas dot read underscore CSV and orders, the name of the file, which is orders.csv. How actually this pd.read CSV works? It parses a CSV file line by line. First row is used as column headers by default. Data types are automatically inferred from the content. The file content is converted to NumPy arrays internally, and it returns a data frame object. Okay, let's print it. Let me just print the data with print df underscore from csv dot head, and number of header I want is 3. Let me just run this again from terminal, and we got 3 headers. The first one is with 0 index and 0, 1, 0, 2. We actually want 3 row. By using these 3 we are getting 3 rows. We can also work with JSON string. Let me just make a JSON file, JSON underscore string, and is equal colon and 3 colon. Let me just make it underscore, not a dash, and in here we'll have that JSON file, which is an array of name. Let me just autocomplete it. The first one will be Alice Smith. Let me just make it Alice. The age will be 28, comma, city will be Dhaka. Let me just create a comma and let me end the second bracket. Ctrl D for duplicating the line. Again I'm going to just make it Bob Charlie, and the age will be 23 and Charlie's age will be 26. The city will be Rajshahi. The city of Charlie will be Sylhet. Now let's make df from, let me just make it autocomplete. This JSON string, it will not work. We are going to need a string IO, which we have imported at the top, and this is how it will work. Let me print it out. Print df from JSON. Let me just run it again. It is not working somehow. Actually the problem is here. In the last item we cannot end with this comma. So let me run it again. Here we got the value. we have name as city and the name is Alice Bob. We can see the table properly. This is from Pandas data frame. Actually, how the pd.read JSON works. First of all, it passes JSON strings or files. Then orient parameter specify JSON structure format. And it can handle nested JSON within JSON normalize. It supports reading from URL directly. pd.read JSON expect a file path by default. To read from a string, use string IO or pass the JSON first. Hope you understand. This is one way of creating data frame. There is another way, which is parse data, and JSON dot loads, it will be JSON underscore string. Then we need to do df data frame from parsed is equal pd dot data frame parse data. Then again print it. Let me just remove the extra space which is not necessary in my case, and here we are again getting all the data table with data frame. Now let's see how we can read nested JSON. For that we need to create a nested JSON, and it will be an array. Inside this array will have name, which is Alice, then comma, actually name is going to be Alice. I'm not sure what did I write actually. Okay, let me just Control D for multiple value. It will be age, that is 33. Again address, this is, let's make it an dictionary again. Address is city Dhaka, and country, actually not country, let's make it post code on 215, and this will be inside double quotation mark. Let me just copy this and paste it below here, and this time instead of Alice, and don't forget to remove this comma from the last item, and in here actually let me just make another field, hobbies, cricket, movies, books. This will be within an array. Let me just copy this hobbies as well after this address. Here in place of Alice, let's make it Bob. The age will be 45 and city will be Rajshahi. Postcode will be 1208. Hobbies will be football, fishing and reading books. Now let's convert this to a data frame. Let's make it df nested is equal pd dot normalize, actually JSON normalize, and this will be nested JSON. Okay, now again print df nested. Let me save it and again run the command. uv run 02. Yeah, here we got name, age, this is name Alice and age is this, and hobbies, cricket, movies, books, football, fishing, books, address dot cities. You see, this is the nested value. We have the address key, and inside this address key, this is another key we have, which is city. City is Dhaka and Rajshahi. Dhaka for Alice and Rajshahi for Bob. And this is how data frame work with nested JSON. Okay, now comes the fun part. We can also read from HTML as well. We can create a HTML table and we can convert that HTML table to data frame in Pandas. So let's do it. HTML underscore string, and here it is. Let's make triple double quotation mark, and this will be a table. Let me just take help of ChatGPT. Create a small table of employee in HTML. Let me just copy this, copy, and paste it here, paste it here. Okay, it should work. Let me take this inside try catch block, try for, let me just pass it for now, except ex exception as e, print e. Every time will not get proper formatted table, therefore it will be an exception if we don't get a proper formatted table. Let me make it table. I also missed it and I must end with table tag, and in here let me just take this and paste it here. Let me format it a little bit better so you can understand what is going on. And in here df underscore list from HTML pd dot read HTML. We can read HTML. We have this function and it will be string IO we need to use in order to read HTML string, then df from HTML. Let me just auto complete it. Again I'm going to print it out, print, here is the value. Let me just run the file again. Yeah, it is saying must pass 2D input shape 134. So it will not be like this, it will be like df list from HTML and 0. Let's see how it looks now. Yeah, it is working properly. Data frame expected HTML table, and this is the HTML table, and it is created from a data frame which got the data from HTML table. Hope you understand. Now let's move into one of the most important part of working with your data, exploring and understanding your data. Because before you do any analysis, before you build any model, before you do any cleaning of your data, you need to actually know what your data looks like. And Pandas gives us some super simple but powerful methods for doing that. Now I am going to create another file with name of exploration. Create a new file, exploration 03 exploration.py. This is the name of my file. In here again I am going to import pandas as pd, then again I am going to import NumPy as NumPy NP, and in here I'm going to create a new dictionary with name of data, and inside this dictionary first field will be ID. Inside ID will have range 1000 on to 0 to on. This is the range, and this range function is Python inbuilt function, so we don't need to import that. Again, I'm going to create another field with name of name. The name, this field will be a type of array, Alice. Okay, I have copied those names. There are a few names in here. Again, I'm going to create another field with name of age. Inside this age, we'll create some random age with NumPy np dot random int. The age will be between, the lowest age will be 18 and the highest will be 40. Let's make it 40 for now. I'm not going to waste a lot of time on writing all of them, so I have just pasted all the values with key and fields in here. And this is salary, the np random int, this is the salary. We want 20 salary in here, and the lowest value will be 18, highest is 14. And in here size will be, let's say, 20 as well. This is size. Department, I hope you understand how this works actually. Now in here we are going to create our data frame with df underscore employees is equal pd dot data frame and data. Now we want to add a value to our data frame. For that we are going to use .log function or method. Okay, OISS, and let me just copy this and paste it below here. Here I'm going to use this method LOC. With this we need to do like this. The square bracket in here, we need to specify the number, the index number, which is going to be 2. In index 2, salary, actually let me just print it out so you can understand better. df employees, and let me comment it out for now. Now let's run uv run 03 exploration, and this is our data. We have this in index 0, we have this record in index 1, and we have this Charlie record in index 2. So I am going to change the value in index 2. So in here we want to change the salary. Okay, and the salary will be now NumPy nen. So there won't be any value. Let me just run this again. Here is index 2 Charlie, and we have salary this. Actually this shouldn't be like this. Okay, in this line df employees, and we are selecting salary column. From salary column we are making it type of float. Previously it was type of integer. Now let me run this, and here it is. Here we got all the salaries in float values. I guess you know the float means. And this none is not working somehow. Actually let's make it none. So let's see, is it working or not? Still not working. So we'll work with it later. For now I'm just going to make it, let me just print it out. Print df employees, then we'll select array. Inside array will have name, then department, then we'll have salary. Before this ending first bracket, we need to do like this. We have used this head method previously. It actually provides us 5 rows by default, but if we specify 3 or 4, it will provide us 4 rows. Okay, so let me just run it. It is not correct. Actually, we need to pass square bracket here as well, and again run it. Yeah, it is working. Now we are only getting name, department and salary. All others columns are excluded. Yeah, now let's print again. Actually, df.tail, this is the function we are going to call now. Print df underscore employees dot tail. By default, the integer number here is 5. We'll get the last 5 rows. So let me just run it again. Yeah, we are getting last 5 rows from 19 to 15 index number, and all those are here. And tail function is also helpful for checking the end of time series data. Usually in real world, it used to check most recent data. Let me just copy this and paste it below here. And in here, instead of 5, we want to get 3 rows from the end. So let me just write it, and here we got only 3 rows. Previously we got 5 rows, now we are getting only 3 rows. We are going to use sorting. This is very important to learn in Pandas. df underscore sorted data. df underscore employees dot sort values. We are going to sort by salary. So by is equal this square bracket salary. Make sure this salary field is inside the data or data frame actually, and this is, we are not going to sort in ascending order, therefore ascending is false. Let me just make it, and here it is. Actually we should do like this. Print df underscore sorted. Let's see how it looks. Yeah, it is sorted now. The first one is 6. This is highest number of salary he got, George. The lowest number of salary taken by Fiona. Now we'll work with information, which is df info. For that we need to do like this. df underscore employees dot info. We should get the information about our data frame. Here we are getting the information. D types, data types is boolean, and date time 64 US on, float 2. Okay, those are all related to data types, and the memory usage is 1.6 kilobyte. All the information you got from this df employees. Then again we are going to use something more advanced. Let me just copy and paste it below. In here, memory usage, let's say memory usage is equal to deep. Let's see how it works. You see, little bit deep. Now we are going to work with describe function. This function is used to calculate descriptive statistic for numerical columns only. Hope you understand by this description. Let me just print it out. df underscore employees dot describe, let's see how it looks. Yeah, it is describing actually. Okay, here the count is 20. We are actually getting 20 IDs. Age is 20. We have salary for 20 person, rating, everything should be 20. So this is the count means. This is mean means the lowest value of age, lowest value of ID, which is on 1000 and on, lowest value of age is 19. The same way you get minimum value, you also get maximum value and standard output as well. And this mean actually mean the arithmetic average value. 25% mean the first quartile or 25th percentile. Same goes for 50 and 75% as well. Let's look into some additional data exploration methods. First of all, let's look into columns. Let's print df underscore employees dot columns columns, and let's take this inside a list. Actually the list will be like this. Okay, now let's run the file, and here we got all the column. We have additional data exploration. This is the print statement we have made earlier, and after that we got all the columns in an array. Hope you understand this. Let me just copy and paste it below here, and here instead of columns you just need to write index.to list. In here you'll get list of all index number you have from 0 to 19 we have in our case. Now one interesting thing I want to show you, that is how many dimension we have in our data frame. To show that, to see that, we need to do like this, n dimension, n dim. Okay, now let's see, it should always be 2 because actually we are getting an error. Actually this is not a list, so let me just get rid of this list and run this again. We are getting 2 because data frame is always 2-dimensional. It won't change anymore. Okay, now let's check total size. Actually the total number of elements we have in our data frames by using this size, and again run this. We got 180. You just count all of them, you will get, actually not all of them, you just count all of them from here and you'll see we have 180 cell. And again we can see the memory usage for this data frame. Let me just call memory usage and run the file again. This is the details of memory usage. We have index of 132, ID 160. This is the number of memory we have used, bytes by byte. We can see how many unique value we have by just doing this, Control D, and in here memory usage, in the place of memory usage, let's make it like this, department dot unique, department, department unique. How many unique value we have in the department? So there are 5 unique value in the department column. Okay, now let's do boolean mask of missing value. So let me just copy this again and paste it below here, or just duplicate it. In here I want to call a function that is null value, is null, and dot sum. How many value? Sum means total. How many numbers of value is null in here? Actually, we got length of 5. We have total 5. Now let's get opposite of null value, which is not na.sum. Let's see how this works. This is actually we are going to get non-missing value count per column. In a column, how many values is not null? I multiplied dash multiplied by 40. Let's see now. Here it is. In ID field we have 20 value. All of them has value. None of them are null. Actually, this is all we are getting with null value. We don't have any null value in here, but in here we are getting non-null value, which is 0. We have value for each cell. Let's make null for one of them. Let me just make it. Yeah, now let's try again. 19 cell has value in salary column, but one of them has null value. That is why we are getting 1. Hope you understand. Let's take a look at some quick statistical functions. Let's do mean salary. So print if mean salary is equal df underscore employees and select salary field, salary, then do call MEAN, and afterward let's do like this, comma dot to f. Let's see how it looks. Okay, here is the mean salary, which is $68,547. As we used this mean function previously, it actually calculates the average of all values in the column. Hope you understand. Like we did for salary, we can also do the same for age. We can get the average age. Yeah, average age is 29.60. This won't have a $sign because this is not a unit. Now we are going to use std function. Let me just copy this and paste it below. Instead of mean, just make it std. This is standard deviation. This actually measures how spread out the values are from the mean. It will be age and it will be standard age. Okay, so let's see. The values standard age is 6.21. If this value is low standard, then values are close to average. If it is high standard, then values are widely spread. Let's call another function, control D, and this is going to be projects, and this will have projects and will have projects dot mean. With this function we'll get the highest value in the column, actually the lowest value in the column. So let's see. We got 1.00, which is the lowest value in the project column. Same goes for min, max. Same goes for max. Let's do a little bit of filtering of this data. So for that, actually it is not it, dt underscore employees, actually not dt, it will be it. We are going to filter by it, so dt underscore employees. Let me just copy this dt, not dt, it will be df employees. Inside this square bracket df employees dot is manager, in place of is manager we are going to check department is it. If department matches with it, then we'll return those data. So let's check it out. Yeah, we are getting quick filtering. Yeah, actually let me print it out. Print it underscore employees. Let's see how it looks. Yeah, we got 5 employees. First one is Charlie, Ian, Michael, Samuel and Tina. All of them has department of IT. Hope you understand. Now we can use multiple condition. This is just only one condition. We can use multiple condition as well. Let me just copy this and paste it below here. And after this we need to take this inside parentheses. After that we need to provide an and sign, not double and sign. There will be only one and sign. In here we are going to pass again another parenthesis. In here df underscore employees is the salary of employees must be greater than, actually let me check, salaries of employees must be greater than 40,000. Let's make it 60,000, so we'll get this 3 value. Okay, so let's make it greater than 60,000. Let's see how it works. Actually let me print it out. This will be high paid IT employees, high paid employees, print it out, all high paid employees. Let me run this again. All of them are high paid employees. We just cut out these two, actually this on. This is how we do filtering. Now we are entering a very important skill in Pandas, something you will use in almost every single data project, that is indexing and selecting data. Because once you have a data set, your real work is not just loading it, it is getting exactly the data you want. Create another file with name of indexing, and this is my file. Let me just close other tab so it won't be any confusing anymore. I'm going to import pandas as pd, and then I'm going to import numpy as np, and here is my data I'm going to use as my data frame. So we have name. This is actually a dictionary. In this dictionary we have name field. Within this name field we have a list of names. We have age field. We have list of ages, city, salary, department, and this is the data frame we have created. Now we have, let me just print it out, print df. We can see we have the data frame with, actually we need to run uv run 04 indexing. Actually this should be 04. So I'm making it sequentially, so you can follow my tutorial and copy my code as well from GitHub repository. Just copy from GitHub repository, link will be in the description of this video. So I'm just making it uv run 04 indexing.py. In here, index is set by data frame. We are getting 0, 1, 2, but we can change the index. We can create totally custom indexes for our data frame, just like this. Let me just make it like this. df dot index is going to be A001. Let me make it 004, then we'll have till 7, 008 we'll have till 7. So let's try it again. Let me print it out here. Indexing, we got A001 to A007 indexing number, and here you see each column has its own name, but for indexing there are no name. We can set that name as well. So let me just make it df dot index dot name is going to be employee ID. So let's see how it looks now. Yeah, it looking great. Actually, in here, let me just clone it. In here, I'm going to get name series. To get name series, we need to use single bracket notation. So just like this, name underscore series is equal df, then the square bracket in here, I'll get name. Let me just copy this and paste it here. We'll get series in here. Yeah, we are getting series. Name data type is string. If you want to get data frames instead of series, then you need to use double bracket. So let me just copy this and paste it below here. Here, name series, in place of name series, let's make it name df data frame, and in here we are using single bracket. Now let's use double bracket for data frame. Let me copy this and paste it here, and again run this. We are getting the data frame. Here it is. And in this data frame, currently we are just selecting only one field, that is name, but we can select multiple fields. Let me just print it out with this. We don't need to initialize anything. df.name comma age. Let's see it is working or not. Yeah, we got name and age as well, and by default we'll get employee ID, so don't worry about it. We can actually select a particular row by position. So to do that, just do like this. Let me just copy this. Let's add a break in here. Afterward, just do like this. Row position 2. This is actually variable, and in here we are going to use df dot iloc, and in here we need to use iloc position 2. So let's see, print, we'll get row position 2. Let's see it is working properly or not. Yeah, we got the third row. Actually the index 2 means the third row, which is name of Charlie, age is 35, city is Chicago. Yeah, you can match it up here first, second, third. This is the third row. Name is Charlie, age is 35. You can see the details up here. We can get the value of a particular cell just like this. Cell val is equal df dot I log. Then yeah, we can just do like this 2 and print here the cell value. Again run this file. We got the cell value for Chicago. Actually, to understand better, let me just add a break here. You can see the cell value properly now. Here is the cell value Chicago. We can select multiple rows just like this. Print df dot I log, and in here just do like 0, 2, 4. This way we are going to select first 3 rows, columns 1 through 3. We can do like negative indexing as well. Just let me copy this and paste it here. Instead of this, let's make it -2. Let's see how it works or not. Yeah, we got the value for negative indexing. Actually, previously we have used log method, and now recently we have used ilog method, but both are different. You know, both log is actually label based, ilog is position based. That means we can get data by index number, and ilog uses rows, columns, integer position, but log uses rows, column names. Let's try log again. Let me just copy this and add this break here, and again let me just write print df dot loc. In here we need to pass like this. Here we need to pass the labels. The labels we have is A001. Then let's select multiple items just like this. A002. Let me just run this again. Here we got this 2 employee with ID of A001 and A002. Previously we have used condition. Now we are going to use the condition again. I forgot to use negative condition. To use negative condition, we need to do like this. Print df, then this tilde key. Actually in here this tilde key, and the first bracket or parenthesis. In the parenthesis we need to pass the condition, which is like this. Name is Alice. We'll get all the value of name that is not Alice, because this tilde key, this is actually a negative condition. Let me just run it again. Yeah, we'll get all of them except Alice. For actually using multiple value matching, we need to do like this. Let me just duplicate it, and let's get rid of this, and we don't need this either. And in here df, and now let's go for city is in let's go with New York City, LA, both of them, and now run this. In here we have a few items or a few employee that lives in New York City or Los Angeles. Those are Alice, Bob, Diana, Edot, George, etc. Okay, we can use between for range. Hope you understand by this how we can use between. Just do like this. Print df age is between BETWEEN. Age is between 25 to 30. Let's see how many employees we get. We are only getting 4 employees. All of them are within 25 to 30 years of old. We can also use string conditions. So to use string condition, we need to do like this. Let me just get rid of this in here. Let's add this square bracket, df, again this square bracket, name. We are going to match str dot contents Bob. We are actually checking if any name is Bob. We can also do like this, bo. Here it is. We have only one name, that is Bob. Let's see, NA. Let's go for NA. Let's see, is there any name that includes this NA? Yeah, we have 2 names, Diana and Fiona. We can also make it case sensitive or insensitive. Case false. Actually, case is equal false. By using this, we are making it case insensitive. Let's do some advanced indexing. Advanced indexing. Let's do result is equal df dot query. We can use df dot query just like SQL query. So df dot query in here, age is greater than 30 and department is equal IT. Let's see the result. Actually this actually we need to use double quotation mark in here, and let's get rid of this and again print result. Terminal. Here we got all the employee that has age of 35 and 32, which is more than 30. This is the condition we have written here in the query. We can use get function, print df dot get. This is actually save column access with default. So get, let's go for department, no problem. And here it is, we get all the department in here, employee ID and their department. Now let's set some value using indexing. The function we have already used, that is log. We can use that log function to set the value. First of all, we are going to copy the data, df dot copy. We are going to copy our data frame. Copy. We have copied the data frame because we are not going to modify our actual data frame, therefore we just copied it. Okay, now let's set value. df underscore copy salary. Actually we need to call the function log, which is the function we have used previously. We are going to use it again, and here we'll call A002, which is an employee ID, and for that employee ID I'm going to change the value for salary. Let's make the salary 80,000. Now let's print df underscore copy. Again run the file. Here we got salary 80,000 for employee ID A002. Now let's set value using ilog instead of log. So let's do it. df underscore copy, then ilog. In here we are going to use this parenthesis df underscore copy, then department. Here I forget to put this dot, then department is equal it and n sign. I have told you what this n sign is. We are actually checking two conditions. First condition is this one and the second condition is this one, and here we must put only one n condition. Unlike JavaScript, we don't need to give two n sign. Okay, and here I will check salary, and the salary will be greater than 80,000. If the salary is greater than, actually let's make it 75,000. If salary is greater than 75,000, then we are going to add a column which is bonus. He'll get 75,000, actually 7,500 bonus. Okay, so let's print it. Print df underscore copy, name, department, salary and bonus, bonus. Let's try again. Yeah, I got an error, cannot index by location index with non-integer key. Actually I made a mistake here. Actually let's make it log for now. I am going to go with column name. So let's use it. Here in the bonus I got bonus for Charlie and E dot. Both of them has greater than 75,000 of salary. Let's set value using ilog again. df underscore copy dot ilog. Here let's put this, and the index will be 0. df underscore copy dot columns dot get log bonus, and we are going to set the bonus to 2000. Again print it. Let's see. Yeah, the first index Alice, he got 2000s of bonus, and this one Charlie, which is who got more than 75,000 of salary, he got 7,500 bonus. Same goes for E dot. We can set bonus for entire columns. So to do that, just do like this: df underscore copy, then set bonus is equal 5500. Actually I made a mistake. Bonus is equal, okay, now print this again. Let's see. Yeah, everyone is now getting bonus of 5,500. Now let's move into filtering data. Because in real life, you don't work with the whole dataset at once. You always ask questions like show me only adults, show me users from Bangladesh, give me products above certain price, find names that start with a specific letter. That exactly what filter is. Let's do some advanced filtering. Therefore, I'm going to create a new file with name of 05 filtering. Okay, let's close all other files. At the very top, I'm just importing pandas and NumPy. Then I am just declaring data. This is data variable, which is a type of dictionary. The dictionary, we got some data, and let's create the data frame from here. df orders is equal this. Now we have order ID, customer name, product name, category, quantity, unit price. Just carefully look at this. We have quantity and unit price, but we don't have total price. Therefore, we are just going to make it df underscore orders total price is equal df underscore orders quantity multiplied by unit price, which is total price. Okay, so let's see, print this. uv run 05 filtering. Okay, here we got order ID, customer name, shipping status, total price. You see some dot. Those actually hiding some data because all data cannot be shown in this table because it requires plenty of space. Now we are going to find out all the orders that is delivered. So delivered orders is equal df underscore orders and df underscore orders here shipping status is delivered. So let's print it out. Actually print delivered orders. From delivered orders, I don't want every field, so let's just select a few specific columns. First one will be customer ID, then total price, shipping status. Let's see. Yeah, we are getting all the items that has shipping status delivered. Okay, I have explained this previously. This is delivered electronics. Here from df orders we have df shipping status delivered. This is one condition, and the another condition is inside this category must be electronics. So again, let me just copy this, and actually let's make it order ID instead of customer ID. So let me just paste it here. Again, run this. Yeah, you know this. We have used this AND condition a few more times. Let's use OR condition in here. Let's make it delivered or electronics. So electronics, this must, let's make sure it is this pipe, so it will bring all the items that has either category of electronics or it is delivered. So let me just copy this and paste it here. Again, run this file. Yeah, we got a lot more file than the lot more items than the previous one. Now let's get some item that start with A. So it starts with A is equal df underscore orders, then df underscore orders, then we have customer name, dot string dot starts with A. So let's print it out. Let me just copy this and paste it below here, and instead of delivered or electronics, let's use this start with A. Here A. Okay, start with A. We got only one item. Actually we must get customer name so we can understand better. Yeah, we got only one customer that name start with A, Alice Smith. We can do same for ends with. So let me just go with ends with A. Customer name ends with A. Actually this should be A. Okay, again we made mistake by writing Alice, but both of them will work. Once you write Alice, it will check any customer that names start with Alice. Here it will check any customer that names ends with A. We can also write condition like this for filtering. Just let me do like this. Long products, make it long products, and here the product name string, then the len must be greater than 7. Copy this and paste it here. Okay, here is the problem we written previously. This is the problem, that's why we didn't get any items that ends with A. We only get starts with, because we didn't use this value as well. And here we need to write product name. Now let's see. Yeah, here are a few products that name length is more than 7. And yeah, actually this is the previous one. It got empty data frame. Let's go for age. Instead of A, just write age, ends with age. So let's go for age. Let's see. Here we got 2 customer that names ends with age. Here we can find all products that is mid-range. So just write like this: mid-range is equal df underscore orders, and in here df underscore orders unit price must be within, just write between 100 to 500. Those are all mid-range products. Let me just copy this and paste it here. Long products, in place of long products, just write mid-range product and unit price. Let me just take a break in here, multiplied by 40. Okay, let's see. Yeah, we got all the products that unit price is more than actually more than 100 and less than 500. Yeah, here it is, all the mid-range products. We can get all the top products or top orders actually. Let me just copy this and paste it here. Top 5 orders, top 5 orders, df.orders dot in number largest, then 5 order ID unit price. Actually we are only going to check total price, so just get rid of this and write total price. We'll get all those products that has highest price. So let me just copy. Actually it is giving me autocomplete, so actually not. Let me just copy this unit price, total price and unit price. Yeah, I made this mistake again. This must be top 5 orders. We'll get this top 5 orders. We can do same for bottom 5 orders. Let me just copy this and paste it below here, and in place of top just write bottom. The function will be in smallest. Previously it was number largest and the total price. Okay, let me just copy this and paste it below here. Again run this file. Yeah, we got all the order that has less total price. Here I'm going to use where clause. Just like SQL, we can use where clause in here. Filtered underscore prices equal df underscore orders fd, not fd, it will be df underscore orders unit price dot learn about where df underscore orders unit price is less than 100. Let's make it greater than, unit price must be greater than 100, and I'm going to print here pd dot DataFrame actually this DataFrame in here, just make it like this. Original will be df underscore orders, and we'll have unit price dot head. After this just make a comma, and here filtered, we'll get filtered value in here, filtered prices dot head. Let's see. Yeah, it is working. Let's use mask. What actually mask will do, it will replace values where condition is true. This is exactly opposite of where function. Let me just copy the whole things from here and paste it here. Let's make it flagged prices, and if it is greater than 100, then make it, instead of where, just make it mask. If it is greater than 100, just make it high price, and flagged prices, just use flagged prices dot head. And now let's see what happened. High price Yeah, original is this is the value. All of them has high price because all of those values are greater than 100. Now let's work with date time filtering. So for that I'm just going to copy this and paste it below here, and again I'm just going to do like date filtered filtered is equal df underscore orders, in here df underscore orders, and order date, we have order date just here, order date, this is date range from 2014, previous 30-day frequency. Okay, df orders date is greater than or equal 2024-01-10. Just go with this on condition. Let's print it out. Print. Let me just copy this and paste it here. Filtered data, let me do like this, order ID and or order date. Let's see how this looks. Yeah, this is order ID and this is order ID, date. All of those orders has greater than or equal this date. If you want to add another condition, you can just do like this. Let me just use this and here. Okay, let's see. We'll get less items here. Those actually matches those condition. I'm not going to explain again because I have explained a few times. Now let's check the order only for January month of January. Jan orders is equal df underscore orders, actually df underscore orders, then in here df underscore orders order date dot dt dot month is equal on, and let's print out the length of the orders, how many orders we got in January, month of January. We got 30 orders in month of January. Now let's work with modifying your data, because in real projects your dataset is never perfect. You will always need to fix values, add new information, update existing data, or transform data to a better format. And Pandas make all of those things very easy. Now I'm going to create another file. Let me just create the file. Modifying.py. Here I'm going to import Pandas and NumPy once again. I'm going to use my orders.csv file. I have created 120 orders. To make it data frame, just do like this. Data frame orders is equal pd.read.csv, and this is the name of our csv file, which is orders.csv. Now let's try printing it out. Orders head. Run the file using the command uv run 06 modifying.py. Here we are getting first 5 rows. Okay, let's modify a specific file. Actually I'm going to copy the data, so the original data will be unaffected. Orders.copy. Now I'm going to work with this df modify. So let's update something in df modify data frame. So To do that, we need to do this df modify dot loc. We have used iloc and loc a few more times. We can do modification with this df underscore modify, then product name. Actually, we are going to check if the product name is equal which product we are going to select. Let me just see this wireless headphones. Then if it match, then we are going to set the product name to, let's make it Bluetooth headphone. Here we are actually modifying with log function. We are using this condition: if product name is wireless headphones, then product name will be changed to Bluetooth headphones. Use this df modify. Yeah, here it is. Let's try again. Now we have Bluetooth headphones in place of wireless headphones. We can even modify multiple cells. Let me just copy this and paste it below here. We are again going to use log function, and this time we are not going to change product name. Instead, we are going to change something like let's change the category. Okay, so let me just copy this and paste it here. If category is electronics, then we are going to change it to something else. Okay, if category is electronics, then we are going to change unit price. Then the unit price will be different than 79.99. okay, unit price will be, let's set some tax is equal 0.8. then we are actually doing, we'll actually do some calculation in here. So let me just copy this line, and again I want to go to the next line, therefore I'm using this sign, and here, okay, calculating this unit price multiplied by tax. This is going to be our new category, electronics unit price. Okay, so let me try this. Before that, let me print it. Print multiplied by 40. Okay, now copy this line, paste it below here. Again run this command. Yeah, we got electronics. This is the first one which is Bluetooth headphones. This is the category of electronics. Now we got unit price 63. Previously it was 79.99. Let's do some string transformation. Let me just go below here, and here df underscore modify, then product name, we are going to make it to uppercase. So let me just copy this again. Whatever product name we have, we are going to make it to uppercase, star upper. Okay, now let's do lowercase as well. We are going to make this category lowercase. Okay, so let me just duplicate it with Ctrl D inside PyCharm. This one will be, actually this one will be category. Copy and paste it here. Instead of upper, just write lower. Then we can also make something title like, so let me just do that. Ctrl D, and here just write title, and we are going to add another field that is going to be product name underscore title. Now the title will be df modify product name string title. Now let's see how it works. Again, I'm going to add this break so you can understand better. Let's see how it looks. Now we have all product names with all uppercase, we have categories with all lowercase, then we have product name title which is at the very end. A column has been added manually. So those are my products name, all of them are in title case. And here this is one of the way to add a column. There is another way to add a column. Let me actually, this is the way we are going to use again. This time we are going to make it total. We are going to multiply by unit price. Let me just copy this and paste it here. It will be unit price multiplied by quantity. In that way we will get our total price. So let me just copy this and paste it here with a multiplication sign, quantity. Let's again add another column. This one will be we can even set static value like this, USD. We can use assign function in order to create a new column. So let's do it. df with discount df underscore modify assign. In here I'm going to pass the name of the column which is discounted price. Let's use lambda function in here. The perfect place to use lambda function, lambda x unit price multiplied by 0.09, actually 0.9. This will be our discounted price. Then again create another column. Let me just copy this by using Ctrl D for duplication. Is expensive. Then we are going to again use lambda to calculate it is expensive or not. If unit price is greater than 100, let me check all the prices so I can understand. Yeah, unit price has greater than 100. So let's, if it is greater than 100, then it is expensive, otherwise it isn't. Okay, we have printed with print statement df modify. We will get only product name, unit price is expensive, discounted price. Let's get this category product. Okay, let's get this currency, and let's get this total. Okay, that's all for now. Let's see in the terminal. Open your terminal and run this command again. We are getting an error. Okay, it's expensive, is not in index. We had used this df modify, now we are using df with discount. So let's see the result. Product name, this is the unit price. It is saying it is expensive or not. If it is, the unit price is more than 100, then it is expensive, otherwise it is not. And this is the discounted price, and currency, this is the total. Hope you understand. Let's use map for replacing values using dictionary. So let's create a dictionary. Okay, this is the dictionary I have created. Status mapping. Previously the status was delivered, shipped and pending. Now I want to change delivered to complete, and which is shipped, that would be in transit, pending will be processing. So in order to map all those values, I'm going to just create a new column and create the mapping. So let's do it. Df modify order. Actually it will be inside a square bracket, as you know. Order status is equal df underscore modify. Currently we have order status, so let me just make it shipping status. So here I want to, actually not here, I made some autocomplete by mistake. So this would be order status to shipping status, and this is where I'm mapping. Let me just print this again, but this time we're not going to use df with discount. Instead we are going to use df modify. In here we have column unit price, and here I need shipping status. Okay, actually not replacing, it is creating a new column with name of shipping status. Let me not use this head so I can show you in transit and other status as well. Here we have processing, and here we have none because there must not be any value, so therefore it is showing none. Let's create another column. This column name will be stock status. Here we are going to use where function for conditional value assignment. So let's do that. Stock status, here we don't need this. Instead we are going to use NumPy np dot where. This is the function we are going to use. df underscore modify, we are going to modify if quantity is greater than 1, then we have high stock. Actually we can do like this, we have high stock, else we have low stock. Low stock. Again print df underscore modify, then we'll have stock status and product name within double quotation or single quotation mark, product name. Let's try it now. We have high stock, low stock, high stock, low stock. Okay, we can rename column as well, so let's do it. df underscore modify dot name of the, actually dot modify dot rename, and in here columns is equal, this is going to be a dictionary. Actually dictionary previously which we have stock status. Now we want to change this to only stock. Let's change it to stock. Okay, now I'm going to print it again. Product name, then we have the stock. Let's try it out now. Yeah, I am getting an error. I don't know why. Actually, I'm not renaming to stock. It is the problem of my autocomplete. It is not letting me work properly. Sometimes it does. Okay, now we have high stock, low stock. We can even rename multiple columns. Just create a dictionary like this. This is going to be the name of our current column. We are going to change this to product. Do same for this one and this one. And here we are going to use the function rename. df_modify.rename. Here all the columns we are going to map and in replace true. Now we are going to print it out. Let's see how it works. We have this product column. Actually, this should be, I guess it will be price. Actually, let's again try. Yeah, here we have product. Okay, again price. Now again try. Now we have product, price and status. Now we are stepping into something that every real data scientist deals with, that is data cleaning. And honestly, this is where most of the real work happens, because in the real world data is never clean. You will see missing values, duplicate entries, messy formatting, inconsistent data types. So before you do any analysis, you must clean your data. Now let's create another file. Okay, cleaning.py. Now let's copy these two lines, pandas and numpy, and paste here. Now I'm going to create a dictionary. Here is my dictionary. This is actually messy data. In messy data we have order ID, we have duplicates value, we have none, we have empty strings like this, and we have none. Now let's fix those data and make it more readable or more organized. First of all, let's detect the missing value. So in order to detect missing value, let's call this function print df_. Actually I didn't create data frame messy data. Let me df_messy. In here is, if you hover over this, it will say what this function will do. It returns a boolean same size object indicating the values are NA, that means non-available value, such as, now let's use this function as well. Now again go to the terminal and run this command uv run 07 cleaning. Okay, here we got all those values. If it is false, it has data. If it is true, that means it is not available. Okay, here the customer name, here it is not available. We can actually count how many total missing values we have by using this is not available .sum. Okay, then again run this. Here we have total missing values of 16. You can just count one by one, it will be 16. Like none, this is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. You can also check how many values are not missing by just writing this print now df underscore missy dot not unavailable. So let's see. Yeah, we got it. Total missing value, here it is. We have all the values which cell returns true, that means it has value. This NA means not available. Okay, let's create another variable. The variable name will be df no NA, then any is equal df underscore missy dot drop. Okay, by the name of this function you should understand what it is. It is actually drop rows with any missing value. How actually this drop NA work? It identifies rows containing none or none. Okay, let's try it out. Print. Yeah, now let's see. Each rows has one or more false value. This one has no false, therefore it is actually returning. Okay, this index 0 is returning, and else all other rows has one or more than one false value, therefore those rows are not returning in here. Hope you understand. Let's add a new empty column. Okay, so let's do it. Let me just create a variable df underscore with actually empty row. I'm going to add empty row is equal, first of all I'm going to copy df underscore messy dot copy and below here I'm going to add a row. So for that I'm going to use loc df, okay, then 10, which is going to be the last row, and non, and this will be actually 8 times. So let me copy and paste it here, and let's print it out. Print df with empty rows dot tail 3. Actually I have to use a function lock, so it will add the row. Yeah, we got the last row with all the value none. Now I'm going to call the function again. Print df with empty row dot drop NA, and in here I'm going to use how is equal all comma tail 3. Let's see. Okay, it has excluded. Now we are going to check if customer name has none or the product name has none, then we are going to drop that row. For that we are going to use df underscore subset fg not df subset drop is equal df messy dot drop NA, and in here subset is equal customer name. We have customer name column actually, and product name. Let's try it again. Try it out again. Let me copy this and print. Here we'll get customer name and product name. Let's see. Yeah, we are getting only index 0, 2, 4, 6 and 7. Those doesn't have any non-value in customer and product name. Hope you understand. For now I'm just going to comment it out. Now we are going to do some filtering for the missing values. Okay, for that, first of all we are going to work with field NA. Okay, so let's do it. df underscore field order id, df underscore field order id is equal df underscore Messi dot field NA. In here we need to pass a dictionary. Here order id is going to be 0 if it is none. Okay, so actually let me copy this, and in here I'm going to paste it here. Customer id, let me copy this and paste it here. Customer name, product name, in place of product name just let's make it order id. Okay, now I've got this order id. This id must be uppercase, so I made that mistake previously. Now I'm going to run this again. Here all the values that has none in order id are getting 0 now, you see, and this is the customer. You can just match with them. Now we are going to fill multiple columns with different values. So let me just create, let me just copy and paste a dictionary for that. Here the order id we are going to fill with 0 if it is none. Okay, the customer name will be unknown if it is none. Same goes for categories, but categories will be uncategorized if category is none. Shipping status, if shipping status is none, then it is going to be not specified. Here I have created a variable. In here I have called this field NA, and here all the values, in values we are just passing dictionary, which is going to be replaced by hot, and here we are just getting all the values we had changed. Let's see how it looks now. Yeah, it is looking great. The customer name is unknown when it is getting none. The category is getting uncategorized if the category has none value, and the order ID is getting 0 if it is none, and shipping status not specified if shipping status is not specified. We have some duplicate values. For example, in product name we have some duplicate values like monitor. We have monitor here and monitor here as well. We have 2 mouse, we have 2 laptop. So we are going to just remove those duplicates. Let's find out all duplicated values, all duplicated rows. For that, let me just write this print multiplied by 40. Again, I'm going to create a variable. Duplicates is equal df underscore Messi in here. I'm again going to use df underscore Messi in here dot duplicated. Actually in here I have used subnet. In customer name and product name, which duplicate we have? customer name we have 2 none and 2 John Smith. In product name we have 2 mouse and 2 keyboard. Those are actually duplicated entries. Now I'm going to drop all those duplicate values. So df underscore no duplicates is equal df underscore Messi dot drop duplicates. Let's see how it looks now. Print df no duplicates. Let's see. Now we are going to drop all the duplicates based on order ID. So df underscore unique orders is equal df underscore Messi, then drop duplicates. Subset is going to be order ID. We won't have any duplicate values. Now let's print it out. Instead of duplicates, let me copy this and paste it here. Let's see all the unique orders. Yeah, we have some unique orders from here to there. Okay, in order ID we don't have any duplicate values, all of them are unique. And remember one thing, here in order ID we have 2 none. Which none you want to keep? You want to keep the first one or the last one? If you want to keep the last one, then you should do like this. Keep last, and okay, the last one will be kept. Okay, this is the order ID, and this is the last one from the last element 1 2 3, the third last. Yeah, order ID 1 2 3, the third last. Okay, hope you understand. Now I'm going to clean this white space or empty string. Okay, so let's do it. For that I'm going to create a new variable. Before that, let me add a break line here, and here I'm going to df underscore print is equal df underscore Messi dot copy. Okay, I'm going to copy everything from df underscore Messi. In here I need to do some cleaning. Df underscore print, we have some empty strings in notes, so let's work with this notes column. notes, let me just replace it with df underscore cleaner. Actually not cleaner, this should be print df print df print, then we will use notes again. This will be square bracket, not curly braces. So here I'm going to use string dot strip. Okay, now let's see. Let me copy this and paste it here, but this time it would be df print in here. Okay, let's see. Actually I'm using 07. Okay, now you see all the empty string has gone. Now it is not showing anything, rather it is showing, actually you should see before, print df underscore Messi. Let me just copy the same this here and cut it below here. This one before and this one is after. So let's see how it looks. This one after and this one is before. We can even replace empty string with a value. So let's do it. Let me just copy this and paste it here. Instead of a string, we are going to use replace. Let me just get rid of this string. This is not part of the string, so this is the empty string. We are going to replace with np numpy none. Let's see how it looks now. Let me copy this and paste this line here. Okay, let me see it. Yeah, we got all none when we got empty string in notes. We can remove white space from column names as well. So let me just copy this. Let me just copy this and paste it below here. df underscore column underscore clean. df underscore columns dot clean dot columns is equal df column clean dot columns dot string dot strip. In here, after strip, we again going to call this str, then replace empty string with this dash. Okay, now let's print original columns, then comma ORI. I always spell original wrong. And with here, let's print the list. This is type of list of any. This any will come from typing. And here df underscore Messi and Messi dot columns. Control D for multiple, Control D for duplicating, clean data, and let me copy this df column clean and paste it here in place of df Messi. Let's see. Again run uv run. Okay, this is the original columns. Actually, I don't have any white space in any one of my columns, so therefore it is not showing any changes in here. Now again I'm going to copy the data with this df underscore dropped demo, and actually let's keep it, just keep it like this. And again I'm going to copy the data df underscore Messi dot copy. First of all, we are going to drop a row with a index number. Okay, so let's do it. df drop rows is equal df underscore drop demo dot drop, and here we are going to pass the index number, which is 3. Okay, here I'm printing renaming index labels. In here df drop rows index to list. Let's see. In the terminal, just run this renaming index label 0 1 2 3. There are no index with number of 3 which we have dropped earlier. In the same way, we can drop multiple. Let me just copy this and paste it here. Instead of drop rows, let's make it multiple rows. Instead of passing just number 3, let's pass this and pass this list. And here I'm going to drop row number 1 and 2 as well. So let me just copy this and paste it below here again. And here let me just copy this and paste it here. Again save it and run the command. Here we are getting all the remaining indexes, Actually in here we don't have any index with number of 1 and 2. We can also drop columns as well. To do that, df underscore no nodes. Actually we won't have any nodes column in our data frame. So to do that, df underscore messy dot, again we are going to call this drop function, and we are going to specify the column names nodes, and axis is equal, axis is equal 1. Now let's print columns after dropping nodes will look like this. This is actually a f string, so let me just put f before the string, and in here it will be a list. It is type of any. So again df underscore no nodes, then columns and columns. Let me print it out. Here we are getting all the columns: order ID, customer name, product name, category, quantity, unit price, and shipping status. There are no column with name of nodes. Now again we can drop multiple columns as well. To do that, we need to do df underscore columns dropped is equal df underscore messy dot drop. In here we need to pass columns, and we need to pass and list. Inside this list we'll put nodes and category. Again let me just copy this and paste it below here, and once again run it. We shouldn't have any category and nodes as well. We have order ID, customer ID. Actually we have category. Let me just make it sure why it is not working. Actually we need to use this in here, and again let me run this, and we shouldn't have any category and nodes in here. Aggregation. This is where you stop looking at raw data row by row and start understanding big picture. Aggregation simply means summarizing your data. Instead of thousands of rows, you turn your data into meaningful insight like totals, averages, counts, patterns. So you are basically asking, what is happening in my data overall? Once you understand aggregation, you no longer just looking at data. You are understanding the story behind the data. Now let's jump into the code and start discovering the pattern together. Again, I have imported this CSV file and created a new column with name of total price, and we have calculated total price by multiplying quantity with unit price. Now we will do some value counts. For that we need to do like this. Actually let me run this if it is working perfectly. uv run. and we are printing data frame in here. After all, we are actually going to do some value counts. This is important for analyzing frequency. First of all, let's create a variable customer counts. Counts is equal df underscore or df underscore orders, and from here customer name. Let me check it again. Do you have any customer name column in here? Product name, customer ID. I guess we don't have any customer name. Let's go with product name instead of customer name. So let me close this, and def orders and product name, then value counts. Let's see, value counts. Now let's print it. Print product counts instead of customer counts. Change the variable name, and again run this. Here it is. We have product name, wireless headphone on, running shoes on, coffee maker, and all of those items we have on product for all of them actually. And we have length of 120 product names. Now we are going to see most frequent product by calling this function print most. This is going to be a f string most product. Most frequent product is going to be product counts dot index 0. In here I'm going to check how many products do we have actually. For that, let's do like this. Products. Let me just copy this. I'm making plenty of grammatical and spelling mistake. I log. This is how we'll get, by using index we'll get values. So this would be products. I think we should go with category instead of product name. So let me just copy this category, and here instead of product name, let's go with category so you'll understand better. Category counts. Let me copy this. Okay, in here instead of product we have used category to make you better understand, and in here we have selected category column. We counted the values, then we used this category counts dot index. Actually, how this value counts work? This counts unique values in a series. It returns a series with values as index and count as values. Then it is stored by count, descending by default. Now let's work with numeric data. And in here, after this category counts, we are going to create a price beans df underscore orders. Orders. In here group by, then we'll group by order status, then size, and again we are going to use this shipping method. We are going to group by both. Let's see how it works. Price beans. Let's see. List object has no attribute size. Yeah, we need to call this size function after this group by function. That is why it is not working. Again, I'm going to call this, and here it is grouped by order status first, all order status confirmed. In here we have shipping method, express and standard, express 3 and standard 2, and we have order status delivered. In here we are actually grouping by shipping method, which we have 45, express and standard 48. Same goes for others as well. Actually we didn't use beans in here, therefore I am just going to rename it to status method counts. Let me copy this and paste it below here. Now we are going to use our aggregation methods. To do that, let me use this print equal multiplied by 40. Then we are going to print total orders. This is going to be a f string. Total orders is going to be len df orders. Then we can find out total quantity sold by doing this. Let me just copy and paste it below here, and let me change it to quantity sold, and we can do like this. Len, we don't need len in here, df underscore orders, then quantity. Actually let's use single quotation mark instead of double quotation mark, since we have already used double quotation mark in this f string, so we are not going to use that again. After this quantity we are going to use this function sum. Okay, by using this sum function we'll get the total quantity we have sold. Now let's duplicate it by just pressing Ctrl D for duplicate. Let's change it to average unit price. In order to calculate the average unit price, let's do like this, unit price, and we are going to actually unit price, we are going to use a function that is not going to be sum, instead it is going to be mean. This is for calculating average as we have seen previously, and here I'm going to use a colon, then 2f. Actually this is going to be a fraction of number. For example, we get a long number after the dot, so it will fraction to 2 digit after dot. So hope you understand. I have shown you previously this. Then average unit price, then I'm going to calculate median total price, median total price. Actually instead of unit price it will be total price, and function we are going to use is median, not mean. So let me duplicate it by using Ctrl D. Here I'm going to find out minimum quantity. We are not going to use total price in here, instead we are going to use quantity and mean. And you know how to calculate the maximum quantity. This is very similar. Maximum quantity max. Now this time I'm going to calculate standard deviation of price. For that, of price, this is going to be unit price, then std. Now let's print out everything. Yeah, everything is working. Total orders we have 120 and total quantity sold 192. Average unit price is 51.16. Median total price is 49.98. Minimum quantity is 1 and maximum quantity is 4 we have sold, and standard deviation of price is 49.60. We can calculate multiple aggregation with AGG function. Let me show you how. Price stats is equal df underscore orders. Then I'm going to use unit price for this, unit price, and this is the function we are going to call AGG. In here I'll do mean. Actually all the operation I need to do is mean, then median, and everything must be with a single quotation mark inside this list, then std, then mean, then max, and the last one will be count. Let me print the price stats. Price stats, again run this file. Here we are getting, actually I am running another file. Now let's again run this, and here we got mean which has matched with this mean. This is the average 51.16. This is the fraction on number we got in here, and median is 34.99. I guess it is not working in actually median total price. It is median of unit price, so both of them will be different for sure. And this is the standard deviation of unit price which we got in here. Again minimum and maximum. Here is minimum quantity and here is maximum quantity, and we got minimum of unit price and maximum of unit price in here. We can use custom function for aggregation as well. So to do that, let me just create another variable with name of custom stats, then df underscore orders, then again unit price, and here I'm going to call the function AGG. In here first one will be mean, and the second function we are going to call is going to be a custom function. So I'm going to create this custom function above here div. This is the function. In here we are going to get a variable, get a parameter actually, return x dot mean minus x dot max minus x dot mean. Here let me print the custom stats again. Instead of price stats, let me put it custom stats, and again let me see. Yeah, it is working. This is mean and this is the range function. We can group by with multiple aggregation. To do that, let me do like this. Category price stats is equal df underscore orders, and here we need to call GroupBy function, and we are going to group for category, and we have created this total price above here. You see, this is the column we have created, and in here I'm just going to print the category price stats. Let me show you again here. Actually, let me make it a little bit clear with this, and in here let's see. Yeah, we are getting actually the reference. Actually, I made mistake here. This is going to be category, and after this GroupBy function we need to use this total price. Then we are going to call this egg function, and in here sum mean, then max, then count. Again, let's call the, here we are getting accessories. The sum of the accessories is this, and this is the mean for accessories, and this is the maximum values of accessories. And how many accessories do we have? We have 4 accessories. Same goes for automotive, beauty, clothing, etc. categories. Same goes for them as well. We can use different aggregation for different columns as well. To do that, let me copy this and paste it below here, and afterward multi egg is equal df underscore orders, then GroupBy category. This is going to be inside single quotation mark or double quotation mark, whichever you prefer in here. And here I'm going to call this AGG function. In here I am just going to do like this: total quantity is equal quantity, and the function we are going to use sum, and this is for total quantity column. And we can use different function, different aggregation function for different columns, as we said earlier. So we are going to use it, and in here I'm going to use average, AVG, average quantity is equal quantity, and it will be mean. Then we have total revenue. Total revenue is going to be total price, sum. This is going to be our total revenue, and this is going to be average price is going to be unit price, and average of unit price we get by using this mean function. Again, I'm going to print it out here. Let's see it is working or not. Yeah, it is working. We are getting total quantity, average quantity, total revenue, average price, etc. all the column we have used, and all the aggregation function we have used for different columns. It is working properly. Here df underscore orders is equal orders, and then here I'm going to create a new column with name of category average price, and in here df underscore orders dot group by, in here category, then unit price. After unit price we are going to call a function called transform mean dot round to. Now let's print it out and see. Yeah, we are getting all those categories here. Category average price is 70, and we have grouped by wireless headphones, running shoes. Those are things we have grouped by. We are getting only 5 items. You can see we have called this function head. By default it returns 5 items, and here we are actually calling this df orders with those specific columns. Now again df orders, let me copy paste this so you can understand better. Copy paste this and df orders, and here I'm going to do some ranking. Price rank in category. Let me copy this group by category till here and paste it here. Then I need unit price. Then I need unit price. Unit price. Then I'm going to call the function rank. This is not going to be actually we got an autocomplete issue. Ascending false. We don't want in ascending orders. We want category which has more price. Then again I am going to call this print below here. Instead of category average price, I am going to call this price rank in category. Let me check it out. Yeah, it is working. Price rank in category, which is in descending order. Now let's create a pivot table. To do that, let me just paste it here so you can see better. And in here pivot on is equal Pandas dot pivot. Actually I spelled pivot wrong. This should be pivot pivot, and in here underscore table pivot table pd dot pi. Yeah, it should work now. In here df underscore orders, then values is going to be quantity. Index is going to be this product name, and here columns is going to be category. Then we need to use a aggregation function. AGG function is going to be sum. I don't know why this happening to me. Yeah, this should be like this. And aggregation function field underscore value is going to be 0. This is underscore, and I'm going to print pivot on. Pivot on. Let's see. We got an error. Unexpected argument full value. Let's see. Full value. This is going to be fill value, not full value. And again try this. Yeah, now we can see our pivot tables. In pivot tables we have category, accessories, automatives, beauty, clothing, pets, etc. All the products name we have in here. This belongs to a category. Actually, let's not go with product name, instead go with something else. Let's go with payment method. Yeah, it would be better, I guess. It would be a better index. Yeah, now we got category, accessories, automotive, etc. And payment method is debit card, credit card, debit card, and PayPal. We have 3 accessories sold with credit card. We have 1 accessory sold with debit card. We have 1 accessory sold with PayPal as well. Same goes for other columns as well. This is how pivot table is. Let's create another pivot table. pivot2. Let me just use this here. In this pivot table we'll use multiple aggregation functions. To do it, pd dot pivot underscore table, then df underscore orders, then index is going to be shipping status, and actually values will be total price. Values will be total price, then index will be shipping status, and columns will be category, then aggregation AGGFUNC. Here we can use a list for multiple aggregation function. Sum, count, then mean, and we'll do fill value 0 by default. Okay, now again print it out below here. Okay, let's go with payment method instead of shipping status. This index is going to be payment method. Let's see. Yeah, we are actually getting this category, accessories, automotive, beauty, and pet supplies, etc. We are getting 66 columns, 33 for sum, and other 33 is for mean. Hope you understand. Let me make it very small. Yeah, here you see we are getting plenty of tables, plenty of columns. Let me make it bigger. Here under sum we have some columns, and under mean we have some other columns. Actually we have same columns under sum and mean. Values are different. It is actually extending columns. Now let's look into something that makes your data instantly more readable and meaningful. That is sorting. Because when you get a data set, it usually not in a nice order. It is random. But in real analysis, order matters a lot. You might want to see higher salaries first, lowest prices first, top performer on the top, or sorted names alphabetically. That is exactly sorting helps you to do. Okay, little bit self promotion. I have created these two websites where I am going to upload all of my tutorials and content about web development and AI automation. So it will be little bit graphical. You hopefully you will like it and get some value from those websites. Here I have created a new file with name of 09 sorting. In here I have imported pandas and numpy, and I have seeded 42 items randomly, and this is the data I have created. If you want to get the same data, just click the link in the description of this video. You'll find the source code. From there just go to 09 sorting and copy this data. Otherwise you can pause the video and write it by yourself according to you. And here I have created this data frame and printing it out. Let me just do it. UV run 09. Yeah, here we are printing the data. Now let's do df underscore sorted salary is equal df underscore employees dot sorted sort values is going to be salary, and this is not going to be in ascending order. Instead it is going to be in descending order. Let me print it out. Print df sorted salary. In here what I want is name, department and salary. Let's try it out now. Yeah, we got all the employees with name, department and salary. This salary, this column is in sorted. It is in descending order, therefore the large value will get at the top and the smallest value will get at the bottom. This sort value returns a new data frame, and here the index is also rearranged. We can also sort alphabetically. To do that, let me df sorted name df underscore employees dot sorted values, and in here we need name, and let's not use this. We'll use ascending false by default, so let's just get rid of it. Let me just copy this and paste it below here, the name and department. Let's get rid of this salary as well. df sorted name instead of salary. Again I made another mistake. I made a plenty of spelling mistake. We got name and department. Name is Alice, department is IT, and all those names are sorted alphabetically. You have noticed that. We can also sort multiple columns. To do that, we need to use df. Let's create a variable multi sort, and in here df underscore employees dot sort values, and in here instead of a string I'm going to pass a dictionary, and in dictionary we'll pass department and we'll pass salary as well. We are going to use this list again. First one is true and the last one is false. That means we want to sort department in ascending order but salary in descending order. So let me just copy this, copy this and paste it below here, and I'm going to use this df multisort. Then again let's print it out. Yeah, we got it. Name, department, salary. We got the department in ascending order here, finance, HR, IT, and the salary in descending order. Let's handle missing values in sort. Let me copy this and paste it below here, and let's add some none values for demonstration purpose. df with underscore na, df underscore actually sorry, let me cut it. I'm not sure why I'm yeah, df employees dot copy. We are not going to change anything in our employees data frame, so df with na dot log, and in index 2 let's performance. Actually in row 2 the performance will be np dot none. Okay, let's do same for this is C not G actually, and let's do same for this time. Let's select row 5. We have printed it out. Now let's see, and we have run, and here is our table. Inside it we have this row 2 and we got none in here, and we have this row 5 0 1 2 3 4 5. Actually not row 5, it is index 5. We have used this log with index and column name. We can also sort our index. So let me just copy this and paste it below here. Now I'm going to copy the data frame. df custom index is equal df underscore employees dot copy, and afterward copy this and paste it below here. Then index is equal e then a, then C, then G, then we have D, then we have F, and lastly we have H. Now let's print it out. Print df custom index is equal name. Okay, let's get rid of this, and once again run it in the terminal. Length got okay, it has 8 elements, so we need to make sure it has 8 elements. 1 2 3 4 5 6 7. We only have 7. Let's include b in here, and again run this. Yeah, we got it. We got all the indexes. The first one is EAC, which we have ordered in here, EAC. We can also sort this as well. So to sort it, we just need to write like this. Create a variable df underscore index sorted is equal df custom index dot sort index. This is the function only we need. Then I'm again going to print this name and department as well. Again I'm going to use another print statement. This is where we are going to have a f string sorted index in here df index sorted dot index dot to list. Now let's see. Okay, this is the sorted index A B C D E F G H. Okay, this is not sorted, and below here it is sorted. Let me just use this sorted index in place of custom index, as I made this mistake plenty of times in this tutorial. For example, if you want to need only 3 employees that has the top salary, so let's get it like this: top 3 salary is equal df underscore employees dot n largest. Actually, I guess I made a mistake, spelling mistake, as I always do. Largest 3 salary, and this should be 3. Okay, now again let me copy this statement, this print statement, and paste it below here. In place of df multisort, let me replace it with this line, top 3 salary. Let's get all the employees. Actually, let's get 2 employees who are youngest in employees. Okay, so let me just copy this line and paste it below here, and youngest youngest 2 is equal n largest n is smallest. Here the only function we are going to change is smallest. Instead of 2, instead of 3, let's get 2, and we are not going to filter by salary. Instead we are going to filter by age. Then again let me just copy this line and paste it below here, and again I'm going to use youngest 2, and let's see. Okay, here I'm getting 3 employees who has more salary than others, and here I have 2 employees who have less age than others. Let me just make it age so you can understand better. Yeah, those 2 employee has less age than others. Let's do some ranking. Let me just copy this. We are going to rank them by performance. Values is equal df underscore employees, then performance, and we're going to copy the performance column, copy, and here it is. Let's sort by date and time. To sort by date and time, we need to do like this: df underscore date sorted is equal df underscore employees dot sort values, and here we have join columns, join date columns. So let me just copy this and paste it here. Join date ascending false. We'll get all the employees that joined recently at first. Okay, so let me just print df date sorted name department join date. Yeah, that's all I need. Yeah, okay, the Fiona who joined 2020 on in the month of 7th and 30. Okay, and the Charlie joined before that. You can see this is who joined later is coming at the top. Who joined earlier is going at the bottom. Hope you understand these sorting things. Let's do some ranking. In here, let's do percentage ranking. For that, I'm going to create a new column, df underscore employees, and the column name will be salary percentage, then df underscore employees, then we'll have salary, then rank pct is equal true. What a miserable autocomplete I am using. Okay, df okay, df employee salary percentage, then df underscore employees, and again we are going to select salary, and we are going to rank on percentage. So let's see, let me just copy this employee here. In place of join date, this is going to be salary, and the last column will be salary percentage. Let's see how it looks. Is salary percentage not in index? So yeah, here is the problem. I need to use this df employees in place of here. Okay, so let's see. Yeah, we are getting salary percentage 0.5, 0.12. This is the percentage. Okay, this is the highest value, and we are getting all other salaries in percentage of this. Hope you understand. Analysis is not complete until you export the result and share them. You don't just work with data, you produce files that other can use. Once you understand saving data, your workflow becomes complete. You don't just analyze data anymore, you deliver results. Now let's jump into the code. Again, I have created this file saving 10 saving.py. Okay, this is the last file, and after saving you should be good to go. First of all, we are going to save the file to CSV. CSV means comma separated values. Okay, to do that, we need to do df underscore orders dot to underscore CSV, and the name of the file is going to be new orders.csv, and index is false. Now let's run this and see if it is saved properly or not. Okay, uv run 10 saving.py. Okay, let's see. Here we got these new orders. In here we have all those columns we have in this data, and all those rows we have in this dictionary. Okay, let me just delete it, and again I'm going to do like this, df underscore verify. We are going to actually verify if it is successfully created the file or not. So df verify is equal pd dot read csv, and the name should be same. Okay, this one. In here let's print out print f string, and in here verification matches, and df underscore verify dot shape shape equal df underscore orders dot shape. Let's see, does it work or not? Yeah, verification shape matches true. Now I'm going to comment it out, otherwise it is going to create a new file with name of new orders. So let me just comment those 3 lines as well. So in that way I'm not going to create a new file. Again, let's create a custom export. Okay, instead of this plain export, we are going to create a CSV file with custom export. For that let me just df orders dot head. I'm just going to export 5 rows from the top to CSV, and in here we can pass many parameters, then just name and index number. So let me pass the first parameter, custom export, and the index will be true this time. This will include index as well, so we'll have 0 1 2. Okay, now the separator, we can set the separator. Let's do it. Separator is equal, let's make it semicolon instead of comma. I'm just showing you how to do customization, but in real CSV file you should use comma. Okay, index label will be row number, row underscore number. Let's use encoding. Encoding is equal UTF-8 signature, and then I'm going to use float format. Let me provide this underscore here, and in float we'll have this, we'll have true fraction number after dot. Then we'll use columns. Columns is equal order ID, and this will be inside a list, so I'm just putting it inside a list. Then we'll have customer name, product name. We don't need product name actually. Then we'll have total price. Okay, we are actually saving this file with name of custom export with semicolon separator instead of comma separator. Then we have included the index with label of row number. Then we formatted float with 2 decimal places after dot. Then selected columns only. Let's see. We are getting an error. Columns, yeah, I misspelled it. COLUMNS. Yeah, this shouldn't be an error now. Yeah, it created successfully. Now let's open this custom export. We have row number, order ID, customer name, and total price. We have only five row, and this is the index number we have included. Then this is the text format. This is semicolon separated, not comma separated, but usually CSV file is comma separated like this. You see, this is separated by comma. Let's comment it out again and delete this. We can also save this data frame to Excel format, Microsoft Excel. So let's use a try. Let me just pass it for now. Then pass exception as E. Then I'm going to print the exception in here where I passed it. df underscore orders, then to Excel instead of to CSV, and the name will be orders export dot xlsx. This file extension is very important. We don't want to include index, then we need to specify engine. Engine is going to be OpenPy Excel. If you haven't installed it, you need to install by using uv add name of the package. It is installed. So now run this again. Let me just run this. Yeah, let's see. We should have a Excel file. This is it. If you open it with LibreOffice or Excel, you can see how it looks. Let me just open it. Open in files, then I'm going to open it with LibreOffice Calc. Here is how it looks now. Okay, we have order ID, customer name, we have product name, category, quantity, unit price, shipping status, total price. Okay, again I'm just going to comment it out. Let me delete it, delete the file which we have created. Not only that, we can save in Excel format with little bit of advanced formatting. Let's do it again. Let me just copy this and paste it below here, and let me just uncomment it, and in try I'm just going to import a few things from OpenPy Excel dot styles import pattern fill and font, then with pd dot excel writer formatted underscore orders dot xlsx. This should be in single or double quotation mark. Okay, and after this, and again we should specify engine, then this will be as writer, and in here df underscore orders dot to excel writer, sheet name will be sheet 1, but I am going to change it to orders, and index is false, org hook is equal writer dot hook, then org sheet is equal orcar dot sheets, and orders, actually this is not orcar, this should be a writer. Now I'm going to format the header field is equal pattern fill, start color will be this, and end color will be this, and let's change the field type. Let me set the field type as well. Now let's change the font of header font is font color is going to be FFFFFF and bold. Then I'll have a for loop of cell in worksheet 1. Okay, cell dot field is equal header field, and cell dot font is equal header font. Now again create a for loop. For now we are going to loop through column in columns, worksheet columns, and in here let's set a max length variable to 0, then column letter is equal column 0 dot column letter. Then again a for loop for cell in column. In here let's use a try catch block, try pass except exception as CE, cell error, print CE, and in here where we passed it, let's check if len string value is greater than max length, then max length is equal len string and cell value. Now below this for loop, I'm going to set a width, adjusted width is equal mean max length plus 2, 50. Then worksheet dot columns dimension, columns, it will be column letter, then width, adjusted width. Okay, this is what we want to fix. Now let's see it is saving properly or not. Let me just run this file again. No module name xlx writer. Okay, let's see. Actually this should be OpenPy Excel, not Excel SX writer. So let's see. Has no object hook. Okay, let's not use this hook for now. Just comment it out again, try it. Yeah, it should be saved properly now. Formatted orders here, let me open it in files, open in files, and in here I'm going to open it with LibreOffice. Here I'm getting all of this. Here I got a colored header, this font is bold, and here all the data I'm getting, and this width is set by our pandas. So hope you understand how much customization we can make with pandas. Not only CSV or Excel, we can also export into a JSON format. To save data into a JSON format, we can just simply do like this: df underscore orders. Before that, let me just copy this so it won't create the same file again. Let me just delete it, refactor. Okay, df orders, then head Let's select 3 items dot to underscore JSON. In here the name of the file will be orders records dot JSON, then orient is equal records, and this would be a single quotation mark in here, and we will not put any C. Okay, the name is this, orient is records, and then we'll select indent is equal to. Let's again run this file. Okay, it should be saved a JSON. Yeah, this is orders record.json file. We have all the orders in JSON format. We only got 3 because we are saving 3 items from here. Okay, and that is it for today's tutorial. We covered a lot. If you followed till here, you build a strong foundation in Pandas. Now it is just practice and real world project from here. If you enjoyed this video and learned something from this video, please do like, comment and subscribe. It honestly helps a lot more than you think. It keeps me motivated to make more beginner friendly tutorials like this.